Hello! In today's lesson, we will learn how to solve linear equations with two variables. In the previous lessons, we learned about which equations in math are called linear equations with two variables. But today, we will learn how to solve systems of these equations. Let's define systems of linear equations with U. A system of linear equations is a set of two or more equations, the solution to each of which is also the solution to the other equation. There are three main ways to solve systems of linear equations. The first method is the substitution method. Let's write it down. Another method is the addition method. And yet another method is the graphical method. All these three methods we will be applying with you. But first, we're going to look at one method of solving systems of linear equations. I'd like to point out to you that you can choose any of these methods to solve the system. But the first method is the substitution method. This is a universal method that can be used to solve any system. Today we're going to be looking at linear equations, systems of linear equations. But this method can also be used to solve quadratic systems, to solve trigonometric, logarithmic, and so on. The second method is the addition method. This is the easiest method when solving systems of equations, but it does not always apply when solving. And the third way is the graphical way. The graphical method is the solution by means of graphs. In our case, if there are two equations in a system of equations, then in order to solve this system graphically, we must first graph these functions and then find the point of intersection of the graphs of these functions, or prove that these graphs have no intersection. Today we will learn how to solve using the substitution method. Once again, I would like to draw your attention to the fact that this is a universal method. If we're going to look at the second method, it's the addition method. We will be adding the first and second equations or subtracting these equations, but I'd like to point out that in this method we can multiply and divide one equation by another. But today we are going to focus on the substitution method. We are talking to you about the substitution method. If we're going to use this method, we're going to be substituting one expression in place of a variable. But let's show you how to do that with a concrete example. Let's consider with you a simple system of equations. First, if it's a system of equations, it's two or more linear equations. And most importantly, in a system of equations, we will find the solution that will be the solution to both the first equation and the second equation. Let's write down the equation. xy equals 8 and x plus y equals 12. Of course, we can immediately find a pair of numbers that will be a solution to the first equation and a solution to the second equation. And you've probably already found that pair of numbers. Let's write down this pair of numbers. And this is a pair of numbers 10 and 2. X equals 10 and y will equal 2. But that's the solution to our system, and we need to learn how to find this pair of numbers. Side. What do we need to do that? If we're talking about the substitution method, I choose any of these equations. But most importantly, in these equations, I choose a variable that I'm expressing through the other variable. In our case, we can choose the variable x from the first equation. or variable x from the second equation. We can choose variable y from the first equation or variable y from the second equation. How do we make this choice? I recommend choosing the variable that has a coefficient equal to 1 and is also positive. But in our case, in the first equation, it's the variable x. So let's go ahead and write down the variable x from the first equation. In math, it's called an exponent. So what I've got here is x equals 8 plus y. Notice from the first equation I wrote down what x equals. If I wrote down that x equals 8 plus y, then that's the expression. I will substitute x for x in the second equation. What is the result? In the second equation, instead of x, I will write 8 plus y. That's my expression equals x. Then I write plus y equals 12. What is the result? I'll rewrite the first equation, x equals 8 plus y. And in the second equation, notice instead of having two variables, x and y, I only have one variable. And then I can solve the equation with one variable. I end up with y plus y, that's 2y's, equals 12. And we'll move the 8 to the right side. Then the solution to this equation is, we're rewriting the first equation because we're not putting anything in the first equation. And from the second equation, we can find the value of y. And the result is that y equals 12 minus 8 is 4, and 4 divided by 2 is 2. So e equals 2. E equals 2. Now, if we have e equals 2, then we need to find the value of x. And then I put that 2 into the first equation. And that's how I find x. X equals 8 plus 2. Notice what we got. X equals, from the first equation is 10, and from the second equation, x equals 2. And that is the pair of numbers that is the solution to our equation. Let's go back to our pair of numbers. The solution to our equation is the numbers 10 and 2. X equals 10, y equals 2. This is the same solution we got using the substitution method. But let's remember that we found this pair of numbers by substitution. If I substitute 10 in place of x and I substitute 2 in place of y, I get 8. And in the second equation, 10 plus 2 equals 12. Then this pair of numbers is the solution to our equation. The substitution method is the most versatile method you can use when solving systems of equations. In the next lesson, we will solve another system. And today our lesson has come to an end. Goodbye. See you again.